Okay, so what I've given you in this problem is these things. So I've given you a cost function, revenue function. I didn't give you a profit equation, but I gave you the formula for finding profit. Okay, and what this is let's see, it says we're going to find production for revenue. So we're going to do like a rates problem for this for revenue then. So let's go down here, and I'm going to write down this revenue equation kind of at the side here so I know what to do with this. So the revenue is 10x minus 0.001 x the second, okay? And let's see, I always want to kind of write down what your information is, okay, when you're doing these related rates problems. So I think I highlighted this. So it says the production is increasing at a rate of 500 flash drives per minute. Now, if it's a rate, you write that in that Leibniz notation. So X is the flash drive. So that would represent dx dt. That's what that is. So that's 500. And it's increasing, so it's positive. So let's write that down as we know dx over dt is again equal to 5,000 of the drives per week. Okay, and let's see, the other thing is it says we're going to find the rate of increase in the revenue when the production is 2,000 flash drives. So that means that X is equal to 2,000 drives. Okay, so what we're going to do is we're going to find the increase in revenue. So what in Leibniz notation, what would be the increase in revenue? dr over dt. Okay, that's a real important thing. So we're going to try to find dr over dt. Okay, so that's what we're looking for. All right, so really all you got to do is you just got to do the derivative of this function right here. Okay, so this should be a pretty easy derivative to do. So if you do dr over dt, okay, well, what's the derivative of 10x? 10. Okay, then we're going to do a power rule here. So you'd bring down the 2 and multiply it, so that looks like that would give you 0.002 x to the first like that. So that's what dr over dt is, okay? Now what we do is we just plug in the information then on this, okay? And the other thing that you want to do on this is the variables don't match, so I made a couple of mistakes on this and I wasn't paying attention, okay? So let's do that again, okay? So the derivative of 10x is 10, but you also got to multiply that by dx over dt, like that. Okay, you got to have that. All right. Again, the t and the x don't match. Okay, so that's why we're doing that. Now we do the power rule, so we have minus 0.002 times x. Again, the variables don't match, so we also have to multiply that by dx over dt. Okay, that's that implicit differentiation that we worked on last week. So does everybody understand that derivative? Okay, remember we're doing dr dt, so we're doing, the t and the x don't match. That's the reason we have to put in that dx over dt. Okay, now we basically just plug in what we know. We do know dx over dt, that's 500, so that's going to go there. And we do know that x is 2,000. Okay, so we'll just plug that in. So we're going to have this to get our final answer. We'll have dr over dt equals 10 times 500 drives per week minus 0.002 times 2,000 drives. And then dx over dt again is 500, and then we just need to go to our calculator and calculate that out. And this should be in dollars per week. We're talking about revenue, so the units on that should be in dollars. Okay, so I'll just do all in one step here. 10 times 500, of course, is 5,000. Okay, and then we have minus 0.002 times 2,000, and then times 500. And let's see what we get there. Okay, so we get a positive number, so that means the revenue is increasing at $3,000 per week. Okay, and what that means is that's talking about when you're producing 2,000 flash drives and when you have a rate of 5,000 drives per week. So that's what the revenue is, okay? All right, that's what dr over dt is. Does that make sense to everybody? Okay. Okay, then we're going to do one last part of this. We're going to do the profit, I think. Okay, so we got to know, we're going to also do the profit. So what we need on this is we know the profit is the revenue minus the cost. So we do have to figure that out. So we need to get those two things. So let's see. Let me write these down. So it looks like the profit or the revenue is 10x minus 0.01x squared. So we have that. Okay, and let me go out and get the cost. The cost is, where is it? 5,000 plus 2x. Okay, so that's what we need to do. We need to go ahead and get that profit done, and then we can finish up the problem in a similar way. Okay, so you just basically got like terms. So you're going to have for your profit, and I'm going to write this kind of in this order. I'm going to put the negative 0.001x squared. Now see, these are like terms. I'm going to go ahead and just write this, though, as 10x minus 5,000 minus 2x. Okay, you got like terms, so you want to put those two things together, the 10 and the 2x. So it looks like your profit is going to be negative 0.001x squared plus 8x and then minus 5,000. Okay, so you weren't given the profit, but you were given the revenue and cost. Okay, yes. Okay, all right. Now the minus distributed through there made that change those signs. Okay. Okay, now we still know the same stuff. So let's see, we know that dx over dt, we still knew that hasn't changed. That's still 5,000, or no, what 500. Was it? 500 drives per week. Okay, and we also know that the production level was 2,000 drives, so x is 2,000 drives. Okay, what are we trying to find on this problem? In Leibniz notation. dP over dt. Okay, so we're trying to find the rate the profit is changing over time like that. Okay? All right, everybody okay so far? Okay, this should be about the same as the last problem. Now what you're going to do is you're going to do your derivative. So you want to go ahead now and do dP over dt. Okay? All right, so the first piece right there is going to be negative 0.002x. Then what?
Times dP over dt.
Then dx over dt. There you go. Okay, like that. Okay. So we're doing a derivative of x with respect to t. Next piece, what's that?
That's
8. And then again, it's dx over dt like that. And of course, the derivative of the constant 0, you don't have to put that there. I'm just emphasizing that. Now, really, all you got to do is just plug in the information. So, and then use your calculator. So we'll have negative 0.002 times x. X was 2,000 drives. Okay, then we have the dx dt, which was 500. And then we have plus 8. And dx dt again was 500 like that. So then you can go to your calculator and see what you get. Okay, so let's see, we get negative 0.002 times 2,000 times 500, and then what's that, plus 8 times 500 is going to be 2,000, okay? So what are the units for profit? Dollars, right? So what we'd get is we'd say the profit is increasing at $2,000 per week, okay, like that. So that's talking about you've got a production level of 2,000 drives. Your rate of production is 5,000 drives per week. The profit is increasing by $2,000 a week, which is good. Okay, if it was negative, what would that tell you? It'd tell you it's decreasing. It wouldn't tell you you're losing, because remember, dP over dt is, well, you are losing because it's negative, but it's a rate, so that rate is decreasing. Okay, that's what that means. Okay, so I'm going to go ahead and give you the